Dear students, in this video, I would like to explain the Viva question and answers for LED characteristics. So first, we must know what is meant by LED. Okay, what is the full form of LED? That is light emitting diode. The first letter only combined to form the LED. So the first question is full form of LED is light emitting diode. The next one is what is the definition for LED? Actually here I mentioned two definitions for your understanding. Both are same only. Just we will go ahead. A light emitting diode is a semiconductor device which can emit light when an electric current passes through it. So light emitting diode is a semiconductor device. So first we must know about the semiconductor. Okay. In this video description box, I will give link for the introduction to semiconductor video so that you can understand what is meant by semiconductor. Okay. And when the current is passing through it, it will produce the light. Right. That is the first definition. And the second one is in depth we are going. Okay. That is the light emitting diode is a PN junction diode. PN junction diode. So if you watch the introduction to semiconductor video, you can understand what is semiconductor and what is this PN junction also. Okay, one more video also I have given already, that is PN junction. Okay, that also you have to. So I'll give the link in the description box. One is what is semiconductor, that is introduction to semiconductor, what is its types, everything we will discuss. And in second video, that is a PN junction diode. Okay, what is PN junction, how it is formed. Okay, and the next one is it is the specially doped diode and made up of special type of semiconductors. So special type of semiconductor means another video also you have to watch to understand this, that is direct and indirect band gap semiconductors. Band gap semiconductors. So these three videos will explain in detail of what is the semiconductor and what is PN junction and what is the direct and indirect band gap semiconductors. So when the light emits in the forward biased, then it is called a light emitting diode. So we must know about the forward biasing also. So forward biasing means in this PN junction only in part 3 I explained. In part 2 I explained what is forward and reverse biasing. Okay, so these things for understanding you must watch it before watching this LED Viva questions. Okay, so now what we understood, LED is a semiconductor device, that is PN junction, and it is a specially doped special type of semiconductors we are using. And when the light, that means when the LED is forward biased, it produces the light. Okay, so here I have given the picture of the LED for understanding. So this is the diagram. Okay, and the next one is what is the symbol of the LED. Already I said LED is a PN junction. So PN junction symbol is this arrow mark under the straight line. This is the PN junction. So this arrow mark represents P and the straight line represents N. So PN junction. So this P is called as anode. Okay, and this is cathode. P is considered it as positive terminal and cathode is considered it as negative terminal. This PN junction is emitting light. Okay, this is the light coming out. The light in the sense photons. Photons are coming out. Okay, so this is the symbol for the LED. That means PN junction and it emits the light. Okay, and one more thing also I mentioned, that is forward biasing. What is forward biasing? By watching the video you can understand, but in simple form I will mention here. This P type should be connected to positive terminal of the battery and the N type should be connected to negative terminal of the battery. So this is positive and this is negative. Okay, positive and negative. So this is the battery. Okay, so P type is connected to positive terminal of the battery and the N type is connected to negative terminal of the battery. This is called forward biasing. So when the LED is forward biased, it emits light. Okay, this is what symbol of this LED. Now The fourth one is what are all the materials used to make LEDs. Okay, so here I have given some examples. For understanding of these materials, you must watch direct and indirect band gap semiconductors. Okay, so actually for making LEDs, we must use the direct band gap semiconductors. Direct band gap semiconductors. So examples are gallium arsenide. In short form, we will write like this: gallium arsenide, combination of gallium arsenide phosphide, okay, and then gallium phosphide and a gallium indium nitride and aluminum gallium nitride, silicon carbide, etc. Generally we have to remember this part, gallium arsenide. So this is the basic material to produce the light, okay, and then different materials are included to produce the different colors of the light. So here I have shown one tabular column for different colors. What are the materials used? Now you see this gallium arsenide phosphide for red, gallium arsenide phosphide for amber. So the color also they mentioned here. See, gallium arsenide phosphide nitride for yellow color, aluminum gallium phosphide for green color, silicon carbide for blue color, gallium indium nitride for white color. So different materials or different combination of materials are used to produce the different colors of the LED. So color is related to the wavelength. So this is what the wavelength of the colors, that also they mentioned here, and the color here. Right. Next question is, what is the principle behind this experiment? How the LED is working? Okay, that is what we are going to understand. Here two things I mentioned. One is electroluminescence and another one is recombination of electrons and holes. So electroluminescence, electro means electrical energy, luminescence, light. Electrical energy is converted into the light energy. So in the diagram itself I mentioned PN junction diode is forward biased. So when the electrical energy is given, the material produces the light energy. The conversion of electrical energy into light energy. So in the short form we used to say electroluminescence. Okay, and the next one is recombination of electrons and holes. So how the light is produced here? See here, this is the positive terminal of the battery, okay, which is connected to the p type. This is the arrow mark represents p type and this is n type. So in p type what will be there? Holes are the majority charge carriers. In n type electrons are the majority charge carriers. So this is first forward biasing we have given. So how the light energy is produced? See the diagram now. So this is p type energy band diagram, energy band gap diagram. Okay, this is p type. Holes will be present in the valency band, and here this is n type. Electrons will be present in the conduction band, right? So now this due to this forward biasing, the holes are forced to reach the depletion region and the electrons are forced to move towards the depletion region, that is the PN junction. So this is called PN junction. Okay, PN junction. So the electrons and the holes are forced. So here this electron will recombine with the hole. The electron directly recombine with the hole and then it produces the light. Okay, so this is the principle of this experiment. So first one is electrical energy is converted into light energy, and the second one is recombination of electrons and holes. That means the electron will jump from higher energy level to the lower energy level to combine with the holes. So by the time it releases energy in the form of light. Okay, so this is what the principle of this experiment or principle, a working principle of this experiment. Next, what is the construction of LED? So this diagram will help you to understand what is the construction. Already I said PN junction. Okay, so P type material and N type material. See here, this is P type material, this is N type material. P and N are combined in the middle. So this is called PN junction. Okay, and here in P type cathode is connected, that is the negative terminal, and in N type the N type is kept over the substrate. Okay, so if it is connected to the anode, this is considered it as anode and it is the positive terminal, and over this some epoxy material will be there, plastic material, to emit the light outside. So from this the light will come outside. Okay, so this is the construction part, P and N, right? Next we are going to discuss about very important that means next we are going to discuss about VI characteristics, that is the exact experiment, VI characteristics. That means I'm going to discuss how the LED will be working when voltage is given. Okay, when the voltage is increasing, how the reaction. So the voltage versus current. If I give the voltage, what about the current? What is the response of this LED material? So that can be explained by this diagram. So already I said here we are going to give the forward biasing. So the current itself is mentioned as forward current. Forward current. So the current will be measured in milliampere. Okay, and then voltage, what we are going to do, voltage should be taken in the x-axis. So here voltage and here current. The current is mentioned in as forwarding current and voltage also forward voltage. Okay, that's what VF they mentioned. For different color they mentioned like this. Now you see we are keep on increasing the voltage, but there is no change in the current. The current is very slowly increasing. Actual diagram will be like this. Up to the threshold, that means up to the barrier voltage, the current won't increase. Okay, current won't increase. The voltage is increasing, but current will be zero only up to the barrier potential. That is up to barrier potential. Okay, once it crosses the barrier potential, then the current starts increasing slowly. At one point of time it increases rapidly. Okay, so from where it increases rapidly, that voltage is called threshold voltage. Okay, threshold voltage or knee voltage also. So what is knee voltage or threshold voltage? The voltage at which the current increasing rapidly is called threshold voltage. Till barrier potential, the current will be zero only. That also we have to remember. Till barrier potential, the current will be zero. Once it crosses, the voltage is greater than barrier potential, then the current is slowly increasing. At one point of time, the current increases rapidly. That voltage is called a threshold voltage or knee voltage. I hope you understand this diagram. This is for different color. So different color will have different threshold voltage. That's what they have shown in this diagram. So different color will have different threshold voltage, right? Next, what are the advantages? So few advantages you can say for the Viva. That is long lifetime, and then energy efficient. No warm up time is required. Immediately it will respond for the current, and it does not affect by the cold temperature. Okay, directional, like that. Anything you can say. Few advantages you can mention for the Viva. And the disadvantages also, it is temperature sensitivity, temperature dependence, and then light quality. So these are the disadvantages. Next, what are the applications? So LED is used as the bulb in homes and industries. This you know well. And LEDs are used in motorcycles and cars. Wherever if you want to indicate, it will act as a indicator. Okay, indicating lights. And these are used in mobile phones to display the message, that is backlight. And then all traffic signals, LEDs are used. These are few applications I mentioned here. Okay, so advantages, disadvantages and applications. Okay, so these are the basic questions which will be asked during the Viva examination. Apart from this, I would like to explain few more, that is general questions what faculty will ask. That is, what is the aim of the experiment? So as you know well, here we are studying the VI characteristics. To study the VI characteristics of LED, that is light emitting diode. This is the aim. And then what is the apparatus required? Okay, so here already I mentioned apparatus means we need LED. Okay, and then V and I, voltage can be measured by using the voltmeter. Okay, and current can be measured by using the ammeter. Okay, and power supply to be connected, that is battery eliminator or battery. So that we can mention it as power supply, power supply. And the next, connecting wires, connecting wires and resistor. That means the current can be controlled to pass through this LED. Otherwise, it will damage the LED. That's what we have to use the resistor also. So these are the apparatus required. So next one is how to draw the circuit. That is also some people will ask. Now listen, how to draw the circuit. Already I mentioned it is the forward biasing. What is forward biasing? P type and the n-type will be there. This is PN junction. It should be connected to the positive terminal. P should be connected to positive terminal of the battery and the N should be connected to negative terminal of the battery. Actually, this is the connection. In this, voltmeter always parallel to the PN junction, that is LED. So LED symbol means light should come out. So here voltmeter should be connected parallel to the, that is PN junction, that is LED, and then ammeter and resistor should be in series. So now you see in this place resistor, ammeter. This is milliammeter, this is voltmeter, this is resistor, and this is the battery power supply, positive and negative terminal. That's all about the diagram. Okay, this is the circuit diagram. So first what we have to remember, forward biasing. Second one is voltmeter should be parallel to the LED and ammeter and resistor should be in series. Okay, this if you remember easily you can give the circuit diagram also. See, for better understanding of this LED, you must watch semiconductor and then types and PN junction diode, how it is formed, and then forward biasing and reverse biasing, and the fourth one is direct and indirect band gap semiconductors. If you watch these videos, you can understand very clearly about the LED experiment. So thank you very much.